Lesson 2.5, scatter plots. From this video, you should learn how to write linear equations that model real-world data and make predictions from linear models. Before we can do this, we need to talk about scatter plots and correlations. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. And a correlation is the relationship or the strength of the relationship between the ordered pairs. There are 5 different correlations that I want you to remember. The first is a strong negative correlation, and that's where the points are close together and they fall down from left to right. The second is a weak negative correlation, and that's where the points are spread apart, but they fall down from left to right. The third is no correlation, and that's when you have no obvious relationship between the points. The fourth is a weak positive, which goes up from left to right, but the points are spread out. And the fifth is a strong positive correlation, which goes up from left to right, but the points are close together. So what we have for example 1 is a set of data. This is all they give us. And I've already went ahead and drawn in the first quadrant graph that you're going to graph it on. You would be responsible of drawing this yourself, but right now I just went ahead and drew it for you. And then you will take your data and you'll graph it on the graph. The question is, how would you describe the correlation? And it tells you to make a scatter plot. So you're just going to graph each point all the way down, and then you're going to look at your graph and compare it to what I've already shown you about correlations and see which correlation you think it is. So the first point is 61, 150. So I'm going to go right to about 60 and up to about 150. This is a scatter plot, so you don't have to be exact. You're just going to try to be close. So that's the first point. The next point is 58, 139. So almost to 60, almost to 140. The next point is 67, 172. So but halfway between 60 and 80, 172 is going to be almost at 180. 79 and 170, so 80 and then up to between 140 and 180. 83 and 234, so past 80 and then up to between 220 and 260. 84 and 255, past 80, up to almost 260. And I think I'm going to finish graphing these and then play the video again. Okay, so all the points are graphed on the graph now. And if you look closely, the correlation, the points are rather close together. And there is an obvious positive climb from left to right. So this one has a strong positive correlation. Okay, again we have data in our table and it asks us how would you describe the correlation. So we're going to graph these points on this graph. All the points are positive, so we're only going to have the first quadrant graph, which is the top right-hand quadrant. And then we go from 0 to 5, so we're going to go 0, of course, first. 1, 2, 3, 4, 5. And then on the test score side, the lowest one is a 57. So I don't want to start at like 10. I'm going to do this little squiggly line, which means I squished my graph. And I'm going to start at 50. Then I'll do 60, 70, 80, 90, 100. You are in complete control over how you do your graph. You didn't have to go by 10s. You could have went by 5s. You didn't have to start at 50, but you did. So your graph is up to you. The only thing that you have to make sure of is that your spaces between your points are the same. So 1, 2, 3, 4, 5, we go by 1, to 50, 60, 70, 80, 90, we go by 10s. You can't go by 10s and then change it to 20s all of a sudden. Okay, so I'm going to graph a few points with you, and then I'm just going to graph the rest of them. and show you the finished graph. So 0, 100 is going to be way up here. 0, 94, halfway between 90 and 100. 1, 98. 1, 88. 1.5, 92. 1.75, 89. Okay, I'm going to graph the other ones and start the video again. Okay, so I have all the points graphed now. If you look at your graph, the points are rather close together, and it's pretty obvious that the more hours spent online, the lower the test score gets. So that's going to make it a strong negative correlation. Okay, the next thing we're going to do is write the equation of a trend line. A trend line is a line that best shows the trend of the data in your scatter plot. So the first thing we want to do to draw a trend line is, of course, make our scatter plot. And you have to have a certain set of data, so we're going to say with the data. Step 2, we are going to sketch a trend line. Sketch meaning it's not going to be exact. Yours may be a little different than others. There is a best line of fit, that's what you're trying to get, but they won't be exact. Step 3, choose 2 points on the trend line. 2 points. And use slope-intercept form to write the equation of the line. I'm going to put y equals mx plus b. So 3 simple steps. First, make the scatter plot, then sketch a trend line, and last, choose 2 points and use y equals mx plus b. Okay, example 2, we're going to draw a trend line. So I want you to pause the video here and draw your scatter plot yourself and make sure that you can actually draw the scatter plot. Check yourself after you play the video again, and then I'll teach you how to do the trend line. Okay, so here's my scatter plot. You can see there's a strong positive correlation, so it'll be easy to write my trend line. I'm just going to sketch a line through these points that goes pretty much in the best route through them, so it's close to all the points, as close as it can get to all the points. Because we're not on graph paper here, I'm going to give you 2 points and then for you to practice. So let's say one of the points was 10, 40,000, and the other point is 55, 110,000. So what you're going to do is take your 2 points, you're going to find slope, so we'll do 110, 110,000 minus 40,000 over 55 minus 10. That gives me 45. And then 70,000. And if you divide that, you get $1,555.56. Or 0.56, and that's going to be your slope. Now you have a point and a slope, so you're going to put it in point slope form, so it's y minus 40,000 equals m 1555.56 times x minus 10. Then you have to put it in slope-intercept form. So you're going to distribute. And I get this, and now we want to put it in slope-intercept form, so we have to get y by itself, so we're going to add 40,000 to the other side. And I get that for my trend line. The last question was predict the price in 2020. Well, 2020 is 80 years past 1940. So I'm going to do 80 where X is. And if you want to see this question, look in your textbook on page 94. The question's in there. And they do ask you about 2020, what the price will be in 2020. That's why I'm doing this. But after you fill it out, you get 148,920. So a good guess on what the prices of a home will be is 149,000.